Topic 1.2, squares and square roots. A factor is a number that divides exactly into another number. For example, 1, 2, 3, and 6 are all factors of the number 6. You can take the number 6 and divide it by any of these 4 numbers, and you still get a whole number. Okay? Here are some ways to tell whether a number is a square number, other than just listing the first several square numbers and then trying to figure it out. That can help you with a lot of small numbers, but once the numbers get larger, it's more difficult to memorize all of those square numbers to figure out whether or not they are perfect squares. So there are some different ways you can use. Here's one of them. If we can find a division sentence for a number so that the quotient is equal to the divisor, the number is a square number. Okay? For example, 16 divided by 4 is equal to 4. When you write a division statement like this, if this number here, the second number, which is the divisor, is equal to the quotient, okay, they're the same, then you know for sure that you have a perfect square number. Okay, it's just basically thinking about it backwards. When we square any number, we take a number and we multiply it by itself. Okay? And you may recall that division is actually just the opposite of multiplication. So we can say 4 squared is equal to 4 times 4, which is 16, then we can go backwards and divide. In other words, 16 divided by 4 is equal to 4. Both of these statements actually prove that the number 16 is a square number. Another way is to look at the factors. 16 has 5 factors. 1, 2, 4, 8, and 16. One way that you can find the factors of any number is to make a factor table. So you write the number you're trying to find the factors of, and you simply list the factors. So I always like to start with the number 1. 1 times 16. Okay? 2 times 8. I know 2 times 8 will equal 16. Okay? How about the number 3? 3 times, well, no, nothing works there. How about 4? Well, 4 times 4 equals 16 as well. Okay? 5 is not a factor of 16, so I think this is a complete list. All right, now when you figure out the factors, you only count each number once. So 1, 2, 4, the number 4 has already appeared, so 8 and 16. Okay, there are 1, 2, 3, 4, 5 factors, just like it says over here. Okay. Now, since there is an odd number of factors, we know that the number 16 is a square number. And we know that because we know that you only count each number that appears here once. And if you have an odd number of factors, that means that one of those factors appears twice on the list. And we only count it once. So whenever there is an odd number of factors, you know that you have a perfect square number. Okay? Take the number 10, for example. Number 10 is not a square number, but let's list the factors anyways, just to prove it. 1 times 10 and 2 times 5. Okay? So we have the number 1, 2, 5, and 10. That is 4 factors. Okay? None of these numbers appears twice in the factor table. So this number is even, and this is evidence that the number 10 is not a perfect square number. Okay, so that is another way to figure out whether a number is a square number, is to list the factors and figure out, is it an even number or is it an odd number? That tells you whether you're dealing with a square number or not. Okay, so back to the number 16, we know that 16 can be shown as a square. Okay, its area is 16, and its side length is 4. Okay, 4 times 4 is 16. We say that 4 is a square root of 16. Okay, the number 4 is a square root of the number 16. And you write that like this. This little symbol here, this is what we call a square root symbol. And it basically does the opposite of what squaring does to a number. It determines what number has been squared to get the number 16. And if we think about it using an area model, like a square, we can think about it as in this little symbol being the area and the answer being the side length of a square. So we would say that the square root of 16 is 4. And that's because 4 times 4 is equal to 16. When we multiply a number by itself, we square the number. Squaring and taking the square root are inverse operations. That's a fancy way of saying they are opposites. They undo each other. Okay, when you square a number and then you find the square root of that number, you're going backwards and forwards. So finding the square of a number and finding a square root of a number are inverse operations. They undo each other. And we can represent that relationship with a table just like this, where we have numbers on the left and we'll square them to get over here on the right. And we have numbers over here on the right, and we'll find the square roots of these numbers to get the numbers on the left. Okay? So to show you how that works, take the number 1, for example. We square the number 1. 1 times 1 is equal to 1. Square the number 2. 2 times 2 is equal to 4. Square the number 3. 3 times 3 is equal to 9. Okay? 4 squared is 16. 5 squared is 25. Now we start seeing some blanks. So we should be able to fill in these blanks with our understanding of this relationship. Okay? So the number 6, we have a blank. 6 squared is equal to 6 times 6, which is 36. How about 7? What is the square of the number 7? Well, it would be 7 times 7, which would be 49. 8 squared would be 8 times 8, which is 64. How about 9? 9 squared, pardon me, 9 times 9, which is 81. And finally 10 squared would be 10 times itself, which is 100. Okay? Now if we think about this backwards, we think about it in terms of square roots, we can take each one of these numbers and do this to it. The square root of 1 is equal to 1. You'll notice that this number is the number that originally appeared over here. Okay, take the number 4. The square root of the number 4 is equal to 2. 2 is the number that originally appeared over here. What we're essentially doing is undoing the square. We're undoing the squaring that we did to get over here. Okay? To get back over there. So the square root of 9 is equal to 3. And this symbol, by the way, you'll find this on your calculator. It can help you, especially with larger numbers, in trying to determine their square roots. And depending on your calculator, you'll have to push it either before or after you enter the number you want to find the square root of. And it will find it for you. Okay? So let's carry on. 16. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7, and so on. Now we go down to the number 10, after which we have blanks. All right, so now we have to start figuring out the square roots of these numbers we don't know. So use your calculator to help if you need to. The square root of 121 is 11. So we can take that number and bring it over here. All right? The square root of 144 is 12. Okay, we can bring that number over here. Square root of 169 is 13. We can bring that number over here. Now you may have caught on to this already, or long ago even. These numbers just increased by 1. So this should be 14 and this should be 15. Okay? But just to make sure that we are on the right track, we can double check by punching this into our calculator. You'll find that we were right about that pattern. Square root of 225 is 15. So we can take these numbers over to the other side of our table and enter them over here. Okay, 15. There you have it. Squares and square roots.